This is 4.2, more implicit differentiation. So I broke 4.1 and 4.2 up into two sections because there's a lot of application involved in implicit differentiation. And so in 4.2, we're going to look at slopes and equations of tangent lines and equations of normal lines, and we're going to introduce the idea of a second derivative, so taking the derivative of a derivative. So let's start with determine the slope of the tangent line to the graph of x squared plus 4y squared equals 4 at the point square root of 2, comma, negative 1 over square root of 2. So key word that we're looking for in here, we're looking for the word slope, and we're looking for the word tangent. It doesn't say find the equation of the tangent line, it just says determine the slope. So we're looking for what the derivative value is given the point that we're given. So let's take the derivative of the equation that we have. So the derivative of x squared is 2x. The derivative of 4y squared is going to be 8y, and then dy dx because we have the derivative of a y. And then the derivative of 4 is 0. So we're looking for dy dx because it says look for slope. Slope is derivative. So let's go ahead and find the dy dx value. So we're going to say 8y dy dx. We're going to move the 2x over, so that's going to be negative 2x. Then we're going to divide by 8y. And get dy dx equals negative 2x over 8y. And then if we want to determine the slope at the point that we were given, we're going to say dy dx at, or such that, x is square root of 2 and y is negative 1 over square root of 2. So we're going to say negative 2, we'll plug in square root of 2 for x, and divide by 8y, and plug in negative 1 over square root of 2 for y. And this is an okay way to leave this, but what we could do is simplify this just a bit. So we could make the numerator negative 2 square root of 2. The denominator would become negative 8 over square root of 2. And then we could multiply top and bottom by the reciprocal of the denominator. So multiply top and bottom by negative square root of 2 over 8 and negative square root of 2 over 8. So by multiplying the bottom by the reciprocal of the denominator, everything's going to cancel out. The 8's will cancel, the square root of 2's will cancel, and the negative signs will cancel. And we'll end up with negative 2 square root of 2 times negative square root of 2 over 8. And cleaning that up, we've got negative times a negative, so the negatives will become a positive. We've got square root of 2 times square root of 2. Well, square root of 2 times square root of 2 is 2, with an 8 on the bottom. 2 times 2 is 4, and 4 over 8 is 1/2, which is much cleaner than what it started off as. Okay, so but this was trying to find slope, so we were trying to find dy dx at the given point. In the next example, the instructions say find the equation of the line. So it's very important that we recognize it does say equation of the line, and it also has the word tangent. Tangent tells us to take the derivative, and equation of the line tells us that we're going to need point slope form. So we've got our equation. We're going to go ahead and take the derivative. So the derivative of x squared is 2x. The derivative of sine of y is going to be cosine of y, and then we also need a dy dx. because we took the derivative of y. On the other side of the equal sign, we're going to have to do product rule on xy squared. So let me draw a box and say xy squared. And that's going to be 1 and 2y dy dx. So that's going to give us y squared, 1 times y squared, plus x times 2y dy dx. And then we're going to take the derivative of 1, which is 0. So there's our derivative. We've been given a point. Now what you can do, in the previous example, we solved for dy dx. And that's one option as you're trying to find a slope. What you could do, since you have the whole equation and you have your x and y value, 1 and 0, is you could just go ahead and plug in right away. So you could say 2 times 1, plus cosine of 0 dy dx equals 0 squared plus 2 times 1 times 0 dy dx. And start to simplify. So 2 times 1 is 2. Cosine of 0, so that, if we look at our unit circle, cosine of 0 is over here. Cosine is the x value. This is the point 1 comma 0, so cosine of 0 is 1. So we're going to say 1 dy dx. And on the right-hand side, we have 0 squared, which is 0. And then we have 0 times a bunch of other stuff, which is also 0. So solving this, we're going to get dy dx equals -2. And that's our slope. So we have our slope at -2. Our x was given to us in the original point, 1. And the y was given to us in the point, and that was 0. So we're going to use point slope form. Y minus y1 equals m times x minus x1. And we're going to say y minus 0 equals -2 times x minus 1. For the next example, this one says find the equation. So it's important to recognize we're looking for an equation. So point slope form. And then this also says the normal line. So we have to recognize that normal means we're going to find a derivative, and the derivative gives us the slope of the tangent line. To find the normal line, that's when we do the negative reciprocal, or the opposite reciprocal. So we have our equation. We're going to take the derivative of x squared plus y squared equals 9. So that's going to be 2x plus 2y dy dx. And the derivative of 9 is 0. And we have a choice. We can either solve this for dy dx, or we can go ahead and just plug in the point that we have. So let's plug in the point. So we'll say 2 times 2 plus 2 square root of 5 dy dx equals 0. And so then subtracting 4, we've got 2 square root of 5 dy dx. So the -4 is going to the other side, because 2 times 2 is 4, and we're subtracting it. Then we're going to divide by 2 square root of 5 and get dy dx equals -4 over 2 square root of 5. So this means the slope is -4 over 2 square root of 5, which I could actually simplify because 4 over 2 is 2. So we could make this -2 over square root of 5. But I want the normal slope. So I'm going to say the perpendicular slope is going to be the opposite reciprocal. So I'm going to flip my fraction, make it square root of 5 over 2, and it's going to become positive instead of negative. So there's our slope. Here we have our x and our y. And so we're going to use point slope form, y minus y1 equals slope times x minus x1. And we'll say y minus the y value in the equation, which is square root of 5, equals our slope, which is root 5 over 2, times x minus the x value, which is 2. And there's our equation. In the next example, we're introducing a new idea that we're going to use quite frequently in the next couple of sections, and it's the idea of a second derivative. So let's talk about this notation, because right now it looks like d2y dx2, and we don't read it like that. We read it as the second derivative. So I'm going to go ahead and say second derivative. And with the second derivative, what we're doing is we're taking the first derivative, which looks like dy dx, and we're taking the derivative of the derivative. So I'm going to use this derivative notation that says take the derivative of the derivative. Well, if I look at the top here, I have a d, and a y. And in math, when we have two things multiplied together, we square it. So this is d2y. And then in the bottom, we have dx and dx, which with really bad notation is dx squared. Okay, it should be that the dx is in parentheses to mean both the d and the x are squared, but somebody decided to take the parentheses away. So that's the notation that we use. Finding the second derivative is an iterative process, which means in order to find the second derivative, you have to find the one right before it. So in order to find the second derivative, we have to find the first derivative. And that process can continue because we have third derivatives, fourth derivatives, fifth derivatives. But in order to find the fourth derivative, you have to find the third. And in order to find the third, you find the second. In order to find the second, you find the first. And so you have to keep backtracking until you've got the derivative that you need. So to find the second derivative, I'm going to start with finding the first derivative. So the x squared becomes 2x. Derivative of y squared becomes 2y dy dx. And that's going to equal 0 because the derivative of 25 is 0. And so in order to get the first derivative in a good position to find the second derivative, we're actually going to isolate the dy dx. So we'll subtract the 2x. So that gives me 2y dy dx equal to negative 2x. And then we'll divide by 2y. And that gives us dy dx. And I'm going to simplify as I go. The 2's will cancel. And so I'm going to be left with negative x over y. You don't have to cancel, but it makes it a little bit easier because now what we're going to do is we're going to take the derivative of dy dx. So we're taking the derivative of this equation right here. Well, to take the derivative of the right-hand side, I have a quotient. I have a variable divided by a variable. So I need quotient rule. Whoops, let me make that look like a U. So I'll write quotient here to remind us that we're doing quotient rule. So I'm going to set up my box and put negative x and y in the upper row. Derivative of negative x is negative 1. Derivative of y is dy dx. So I'm taking the derivative of the derivative, which means I am finding the second derivative. Whoops, not third derivative, second derivative. So I'm going to do negative x times y, so negative y, minus negative x dy dx. Okay, so I did -1 times y, so this was this diagonal, and then -x dy dx, which got me this, and I subtracted them, which is how we got a positive. And then I'm going to divide by my original denominator, which is a y squared. When we find second derivatives, we don't leave the first derivative notation in there. So what I'm going to do is I'm going to say d2y dx2, so the second derivative, equals, and where I have the first derivative notation, the dy dx, I'm going to go ahead back over here and substitute this in right there. So I'm going to have x times -x over y. And I'm going to divide that by y squared. So now I've got a weird like fraction within a fraction thing, which is okay to leave. It's not usually something that we leave, but it's okay. But what I can do is I can take the entire numerator and the entire denominator and multiply them both by y over y. So I'm multiplying by 1, but it doesn't look like 1. So that means now in the denominator, I have y cubed. In the numerator, this y gets distributed here and here, so both terms. So I'm not going to make this -xy over y because the y's are going to cancel. So I'm going to be left with -y squared, because I did y, the y on the outside, the red y, times the green y. And then the y's in the next term canceled, so I'm just left with -x squared. And this next trick is kind of fun, because I'm going to factor out the negative sign and make this x squared plus y squared over y cubed. And then I'm going to go all the way back up to here, because x squared plus y squared is 25. And there's my answer. So this was a circle, x squared plus y squared equals 25. This will work for any circle. So if it was x squared plus y squared equals 4, x squared plus y squared equals 100, it's going to work for any of the circles that you could possibly have. Next page, let's make this a little bigger. We want to find the second derivative at a given point. Now these are kind of nice, especially when you've got some ugly looking implicit differentiation equation. So I've got x cubed plus y squared equals 3x plus y minus 2. And we're trying to find the second derivative. So what I'm going to do is I'm going to start by taking the derivative, the first derivative. So 3x squared plus 2y dy dx equals 3 plus dy dx, and the derivative of minus 2 is going to be 0. And I'm going to go ahead and I'm going to isolate the dy dx. So I need everything that has a dy dx, whoops, on one side, and everything that doesn't have a dy dx on the other side. So I'm going to say 2y dy dx. I'm going to move the other dy dx over, so minus dy dx. And then on the other side, I'm going to have the 3 that was there, and then I'm going to subtract the 3x squared, so minus 3x squared. And now I can factor out the dy dx. and get dy dx equals 2, or times 2y minus 1 equal to 3 minus 3x squared. And then I'm going to divide the stuff in parentheses. So I'm going to get dy dx equals 3 minus 3x squared over 2y minus 1. Now remember from the previous problem, we had a dy dx in our second derivative that we had to replace. The same thing is going to happen here. So before I move on and do my second derivative, I'm going to actually find the value of my first derivative, so dy dx, at the point I was given, 1, 1. So I'm going to do 3 minus 3 times 1 squared over 2 times 1 minus 1. So let's see what we got. That's going to give me 3 minus 3, which is 0, over 1, which gets me 0, which is kind of a nice value to have in these problems. So now I'm going to go ahead and I'm going to do my second derivative. Well, right now my first derivative is a quotient. So I'm going to go ahead and I'm going to put 3 minus 3x squared in the upper left, 2y minus 1 in the upper right, and take the derivative. So the derivative of 3 is 0. The derivative of minus 3x squared is minus 6x. The derivative of 2y is going to be 2 dy dx. So the second derivative of y with respect to x is going to be negative 6x times 2y minus 1 minus, and lots of parentheses here, 3 minus 3x squared times 2 dy dx. And that's going to get divided by 2y minus 1 squared. Now, rather than try and algebraically simplify all of that, remember, we want the second derivative at the point 1, 1. So let's go ahead and say the second derivative with respect to x at 1, 1 equals. And we'll do negative 6 times 1, and then 2 times 1 minus 1, so we're just plugging in 1 for x and y, minus 3 times 3 times 1, or 3 minus 3 times 1 squared, times 2, and then dy dx, which we already know is 0, because we found it already. And then I'm going to divide by 2 times 1 minus 1 squared. So let's see what we get. That's going to give me, let's see, 2 times 1 is 2, minus 1 is 1. So that first term gives me negative 6. The second term, we've got 3 minus 3 is 0 times 0, so that's going to be minus 0. And then in the denominator, we've got 2 times 1 is 2, minus 1 is 1 squared, which gives us negative 6. And I think that's it for this section.